My name is Jéssica. This is Dominik. We both work at Ecosia. So Ecosia is a search engine that plants trees. So it's similar to Google, DuckDuckGo, but with the difference that we plant trees with our ads revenue. And today we will talk about Go. And we were before. Yeah. Oh, right. What is this? Right. Thank you. Yeah, so we both work with Python before. And today we want to show you about how it's working with Go, and we'll create a small project. And then we also want to show you the perspective of working with Go, but from a perspective of being Python developers. And then now Dominik will say you more about how it's Go and its advantages.
Can I organize the first topic? I was told we should use the mic because we might be being recorded. Are we recorded? Because otherwise we'll not use the mic.
Please use the mic anyways.
All right.
Yeah. Okay, so. Sorry.
Right. Is that working? Kind of? Cool. So first we want to tell you why you as Python developers would even care about Go. And there's some points here. One of the reasons you probably heard a lot, it's fast. And from our experience, that's pretty much true, so that's cool. If you need to, you can do system level development, which can be cool if you need to do these kind of things, but it's much nicer than using C for these kind of things. One of the big reasons why yeah, that would be nicer. One of the reasons why we're using it at Ecosia is because it has web kind of built into its standards library. So you can do a lot of web stuff like sending requests, but also starting a server, all of these kind of things, just with the standard library in a really, really nice way. And also it has parallelism built right into the language, which, especially as a Python developer, I think here's the main difference. You can do a lot of these things in Python, it's just way harder to do so. It's a typed language, you might like that or not. And it has kind of an interesting concept of interfaces, things that Python kind of does with inheritance, you do with interfaces here, and I find it at least interesting. I wouldn't necessarily say better or worse. It has a very extensive standard library, which is something you know from Python, but if you, for example, had to use JavaScript, you sometimes have this feeling, oh yeah, there's something missing maybe. And yeah, as I said, web is so much built in, and it has even like an HTML rendering, like template rendering engine built in right in the language. And it's heavily inspired by Python. I mean, that's a good reason to use it, I guess. As the title kind of promises, this is mostly going to focus on parallel programming. And I already said this may be a little bit tricky to do in Python. And here's some of the reasons why. One of them, maybe you heard the talk yesterday about the GIL. Yeah, so the most commonly used Python implementation, CPython, has a global interpreter lock, which for a lot of scenarios might not matter as much, but for some scenarios is still relevant. Yeah, you could use something like multiprocessing to kind of work around that, but then the cost of running all of these heavy processes, it's memory intensive, exchanging messages gets quite expensive. So you might not want to do that. And the way Go is structured, because it's right built into the language, it's very nice to do things in parallel. You barely notice. In Python, you have to jump through a lot of hoops, doing threads, using queues, to somehow synchronize, having mutexes, all of these kind of things. And especially talking about mutexes, in Python, most of the standard library is not thread safe. So you have to make sure parallel access is fine. Go, on the other hand, as I said, has parallelism built right in. It has a very interesting way of doing parallelism, which is called Goroutines. I don't want to go into too much detail, but it's basically you can run several Goroutines concurrently in a single operating system thread, so you can have parallelism on a sub-operating system thread level, but also it can pan out to multiple threads if necessary, and it kind of handles that in the back itself. So it's super lightweight, it's super automated, and it's just pretty nice. Also, you have the Go keyword, which is basically the only thing you have to do to run something in parallel. You have your function, you write Go in front, it's parallel, there you go. That was not a plan. And it has channels to kind of synchronize access between these Goroutines, which is a very nice way to send messages between Goroutines. And you don't have to think about race conditions, you don't have to think about locking. All of these things are just kind of magically taken care of. And as I already said, in Go, the standard library is pretty much thread safe. So pretty much everything you can use, you can use it in a Goroutine and share between Goroutines. Also, because the core language is that way, a lot of packages written by third parties, like open source packages, are written in a thread safe way as well. All right. Awesome.
Can you hear? Yeah. So today we'll show to you most of these strengths from Go, especially because Go has a strong HTTP library. So we will take advantage of that and use today. And we will build this small project, which is a kind of a smaller version from a project that we have at Ecosia running in production. We will run several APIs concurrently, and we will just parse the response and show to the user. And in this case that you guys are attending a live session, we ask if you have any questions in between, like, because we will do some live programming, so you have any questions, we just ask the person that is not presenting so we can try to help you. Right, so I actually need to change. Yeah. Cool. So everyone has access to this repo. Does everyone clone the repo and it's locally? So I'll start, but in between you can clone this as a base. And actually we can start just with everyone has access to this URL? Yeah? Okay. So actually, you can clone if you want, but we can start creating an empty folder. And you can just add this new go.mod file with a module and the Go version. Right. So the first thing we will do, we will basically call a very simple endpoint. So this is how the endpoint looks like. It just returns a list of colors, and the value is always kind of random, just a hexadecimal. And I'll start creating a new file, which we will call main.go. This will be the entry point to our project. And I start defining package main. And then here we we start defining our main function. So here, similar to Python, the difference is that in Python you would do something like if name equals main. So that is equivalent to that in Python. So here will be the first entry point to our project. And for now, we didn't implement yet the call to the API. So I'll just write this. Let's just call api.callxbot. And then this will return a response and an arrow. So different from Python, in Python you just raise an arrow and then you catch it in the try except block. In Go, we actually expect an arrow variable of type arrow in Go. And then we would do the validation manually. So we would do something like if arrow different from null, and then we would treat the arrow. But for now, let's just not do that. Let's just ignore the arrow. And we will just print the response. This is just a special way to format the string. And then we do the same for the arrow. Cool. So now we want to implement the call to the API. And
sorry that you added it, but maybe there's. Can you mention the empty just because?
Sorry. So Dominik just remember me, since I'm using the VS Code, so it handles imports automatically, and I have like a Go plugin that just handles syntax and imports and everything. So what happened is that when I added those two lines to print the response and the arrow, it also imported the FMT package from Go, which is just the one that we can use for printing things. Also has things for arrows, and you can also print arrows and format arrows, strings, and everything.
How do we do this without the tool? Do we do import the module with Go directly?
Yeah, you can do like import FMT.
Just Go import FMT.
Yeah, you just add to the file, import FMT, and then if you have Go installed, when you run this go run main.go, then would just work, hopefully. Yeah, exactly. It's already built in. Actually, for this first part, is everything is already built in the language. So we won't do, like, we wouldn't need to install any specific libraries outside. So now we can create a new folder. Here we would have the call to the API. Just call xbot.go. And you see that the response that we have is very simple. It's just like a list of colors, and each element has a value. The value is a string. And at that in Go, we would use structs to parse the response. So I'll show you. Like, we would basically mimic the same structure that we have in the response. So we would call type export response struct. And then here we define our list of colors, which is also a struct. List of, like, each element is a struct. and then inside the struct we have the value. So here Go will see, okay, I have a colors, I have value, and then it will match automatically with the structure that we defined, that is defined in the JSON response. So now we can start implementing our function that we call function call xbot. And as we saw here, we expect that this function returns a response and an error. So here in the return, we will just write like this. And now is the nice thing. So here we call http.get. So again, this is already built in the language. You don't need to install anything from outside. And we can just put our URL here. And in this case, if it returns an error, what we do is that we check. If we have an error, we just propagate it. So in this case, we don't have any response, actually, because we had problems. So we return new, and then we propagate the error, which will be used in this, the main function, and then we can do the validation there. And then now we need to actually parse the response, the JSON response, into our struct. Let's just create another function. For that, we can call function onMarshall xbot response. And this function will receive a response of type HTTP response. And then we will return here an xbot response and an error. So here you see that I'm using this notation. So this is to indicate that this is a pointer to a struct, which is our struct. So in Go, it has this concept of pointers. It's more explicit. It's actually explicit, which in Python we don't care about. And I'll not get into detail on that, but for now we just accept that we are returning a pointer to the struct, and that would be more efficient because we are not returning the whole struct. So we just return a pointer to it, and then we can save, like in performance would be better. And then here we can start parsing our response. So we create a new variable of type xbot response, which is our struct, and then we call it parsed. Yeah. So this is just to say that is a variable with name parsed of type xbot response. Line 11. Yeah. So here in this case, because I'm creating the variable. So we have different types, different ways of create variables in Go. So you can use like this, or you could also use this notation, like xbot response, and then here expects that you create already. And also this 2 points, it indicates that is a new variable. So it's, I was just reassigning, would be something like this. Yeah. Yes. Cool. So now we have a new error that we expect because now we would use this method from JSON, which is also included in the library in Go. And then we pass the body of our response to this new decoder. And with the result of that, we decode what we got into our parsed struct. So now we send a pointer to the parsed variable. And then this would already fill the struct with the values from our response. And then we return this, so return the pointer to the parsed and the arrow. And then now we want to call this here inside call export because we want to fill our struct. So let's just return already our function on Marshall call export response, passing the response that we get from here. And actually we can use this in a new constant, to make it more explicit and better. So let's just call const, which is a constant, xbot URL. Then we use here. And then this http.get, I forgot to mention, it's like a request in Python. I am true. Thank you. And of course, I forgot to add here the package API, because now we created a new folder called API, and then we need to specify the package. Cool. So now we can try calling. You see again that the package was automatically imported. So now we can try running our main function. And for this, we just use go run main.go. Now you can see the response. If I call again, it should do another request. And for now, we don't get any errors. Yeah, so this is because, like in Go, you specify the path to the package. In this case, we are using from API, and this project is cloned inside this this path. No, I don't think so. Yeah, you would need to write like this.
From Java, where they also have this com dot whatever kind of it's to make things unique, so it's tied to the GitHub URL or any Git URL.
Yeah.
Now with Go modules, which is the new thing we did, if you open this up again, we actually get to specify the themselves. So we provide whatever there, but still
Yeah. Cool. So now you can try yourselves. So the idea is that we call another API, and you can see the instructions in the GitHub repo. You go to the second API call folder. So it's basically the same, but with the difference that now the API that we call returns a different response, and it's another API. So you would mimic, so we would add here new vexbot.go file, do all the parsing from the response, and then adding the call. Sorry, adding the call from the main function. So we will give you 20 minutes? 5? Okay, 5 minutes.
Come again? Yeah. So I mean, this is why it's structured in several steps. So you don't, if you, well, can you say that word?
Yeah.
All right. So there was concerns that maybe not everybody can follow in that speed, and that's completely fine. It's split up into several steps. Each step contains all the code that was written before. So if you get lost somewhere in the middle of a step, just wait for the step to be over, copy paste the next step, and you're good to go. So everything we just wrote in this repository, how do I? Is actually in step 1, API call, and this has all the code we just wrote. So if you get lost, you can just copy paste it from there and follow from the start of the next step. All right. So in an ideal world, you all now would run the command and see something like this. Because you're not living in an ideal world, feel free to, as I said before, just go into the repo, go into second API call, and copy the file vexpod.go and main.go and replace what you currently have in your folder. Then we should be at the same state again, and you should hopefully be able to follow me from there. Jéssica is still running around, so she can still support you in debugging things, getting things to run, but because we also want to make some progress, I'll just go ahead. All right. So in the next step, in the introduction, when you saw it in the schedule, we talked about wrapping this whole parallelism thing into a small abstraction that we call a job. And this is what we're going to do. There we go. And again, we make a new folder called jobs, which is also again going to be our package name. And we create a new file, which we're just going to call base.go. This is going to contain our base interface, which if you have some Java experience, interface might ring a bell. Otherwise, in Python, it's more the same concept as an abstract class. So you kind of define a blueprint of all of these things should have these methods. And in Go, this happens like this. So, as I said, let's start with the package name. So Go doesn't have classes. So if you want to write methods, you have to attach methods to something. And actually that something in Go can be pretty much whatever you want. The kind of default, if you don't know any better, is using a struct. But you could be using a string. People would probably look at you a bit weirdly and ask you, why exactly do you pick a string? If you want to extend a string, that's cool. For anything else, if it doesn't matter, use a struct. We already defined struct, so that looks something like this. And I'm normally not typing on a US keyboard, so I managed. Perfect. And as before, when we wanted to parse our JSON, we can just have arbitrary fields in there with arbitrary types. We think it's kind of nice to have an ID for a job, so we can tell the different kind of jobs apart. Sorry, that's a job result. So we want our job to return something, and that should have the same ID as the job. It should have a result, because that's what it's wrapping. And if you don't know the type of something in Go, because it's a typed language, you have to say something. And this is the so-called empty interface. An empty interface means I accept anything that doesn't implement anything. So it's basically no expectations. Anything passes through this. So that means I can put every type into this thing. And as you already saw before, Go likes doing error handling with explicit errors, so a job could return an actual result or an error. So now to the thing I actually introduced, the job interface, which we actually call an interface. And just to be able to kind of tie the result and the actual job together, this one has a method called ID, which should ideally return the same string as ID in the result up there. It also has a method called start, which basically means start doing your thing, please. And now there comes something that syntactically looks a bit strange. What does that mean? That means we have something that we were going to call done, and here the name doesn't actually matter. Of type channel job result. So this is both together is the type. And that means this is a channel that we can send job results over. Channels are something we use to synchronize Goroutines. And you're going to see how we use that later. But right now that just means this gets past a channel of that type. It's a little bit like a callback in JavaScript. I mean, you can also do callbacks in Python, especially if you do it async IO maybe. So this is a similar concept. And we also want to be able to actually cancel a job. Right. So this is basically saying if we expect a job, we expect that job to have an ID method, a start method, and a cancel method, which is pretty much kind of formalized duck typing, right? It's like, we should be able to do these things. We don't care if you inherited from somewhere, if you implemented it yourself, or wherever you got these methods from. Do whatever you feel like. You just have to have these methods. Right. Let's also actually implement an example job. And we're going to implement a job that wraps the Hexbot API call. So we're just going to call it Hexbot as well. Right. It's in the same folder, and in the same folder, things have to have the same package. So let's do that. Also, I mean, you saw before, we kind of have a lot of things called IDs. We should probably define some ID somewhere. Quotes are here. Yes. And it's just going to be the string Hexbot. Right. So before I said, if you want to have something that has methods, that something ideally is a struct. So that's what we're going to do here. And you can see this is just an empty struct, right? It doesn't have any fields, because the fields don't matter. What matters is the methods. Right. How do you write a method onto a struct? It's not that obvious, and the syntax is a bit weird, but once you wrap your head around it, it's at least understandable, I guess. And I'm going to write it out, and then I can explain what that means later. Right. So this basically means, if you forget about this thing, it's just a function, right? This is just a function called ID that returns a string. This basically means this is a function, and the first thing is called a receiver. This is a function that can do things on Hexbot, which technically makes it a method on Hexbot. And the age there is pretty much the same as self in Python, right? So this gives you a reference back to the struct. We don't actually going to use that. We're just going to return our ID here. Right. We also said we have to have a cancel method. So let's write that one. Again, same thing. We have this receiver argument. Yep, that is correct. Thank you very much. That looks better. Oh yeah, thank you. I also forgot the right struct here. Right. We're going to do the cancel in the next step, so this is just going to print. And we said we have a start method as well, so let's implement that as well. And we said that gets something called done, which is a channel of type job result. And we said what this job is going to do is rep the API call. So we should probably call the API. And then we had this wrapper around the result, which we call job result. And we said this has an ID, which is just the export ID we already saw. It wraps a result, which is whatever type. And in our case, this is going to be the response. And it has an error, which is error. So now, if this would be a normal function, we just do return result and be done, right? But we said we're going to use this in a parallel fashion. We're going to use this in a Goroutine. We kind of want to use channels to not care about synchronizing things. So instead of just returning it, we write it into the channel. And the syntax for that, if I find that on this keyboard, looks like this. So this basically means put res into the channel done. It's very similar to return. This won't stop execution though. So if you write code afterwards, like here, that would still get executed. So in that regard, it's different from a return. Right. You know constructors from Python. That's the lovely thing that is called under init, right? Where you can initialize things. We don't have classes here. So constructors don't really work that well. But there is another pattern that kind of was established in Go, which is so-called new method, function, sorry. And that's basically just a function that returns a new instance of that type. And right now that is super not exciting because you're not actually going to do something. But this would be the way where you can do all the kind of things you would do in an init. Nothing is preventing anybody from the outside to just do that themselves, right? It's a convention. So they can use new and then get all the initialization that you think is meaningful. They can step around it and do that themselves. Because we're going to have several jobs in the same package, the names have to be unique. So let's call it new hexbot job. Right. My IDE, lovely enough, fixed all the things for me. So make sure you have all the imports here. And I mean, we're not using that job anywhere yet, so it shouldn't change the output, but it should ideally still run, which it does. Which means I'm going to hand over to Jéssica.
Right. So now we defined the jobs and everything, but we actually want to use it and call it from the main function, which is still calling directly the API instead of calling the job. So now what we would do is that we define a new channel. Like we define a new variable actually that creates a channel of type job result. And this is from Go as well, built in. So this is how we create a channel, and you can also use for other things like map and other types of variables. So let's comment this for now. And then here we can call our xbot job. So we just use jobs dot new xbot job. And the interesting thing now is that we will run this job in a Go routine. So then for that, we just use Go, the keyword Go, and then we start the job inside this new Go routine. So that we already run concurrently with our main function. So now we do the same for vexbot. I didn't wrote yet. Okay. Okay, so instead of... Yeah, let's do this for now. And I'll just copy, because, in the tutorial, in the Git repo, we have the vexbot job as well. So for now, I'll just copy to save some time. And... So here would be also very similar to the xbot. Okay, so also the same structure. Calling the API inside the start. And then, of course, we need to import the packages. Which sometimes work automatically, not sure why I didn't. Okay. And then we also put inside a new Go routine, the vexbot. Just puzzle why we don't have vexbot job. Yeah. So Dominik just should suggest me to run, because sometimes I have also problems with this IDE. Let's just see if those jobs are defined. So base, package jobs. Yeah, okay. Right, it was just this file that was not saved, apparently. Let's just try again. Cool. Yeah, so now we don't have no problem. It's also, I didn't enable the autosave, so not sure why. Sometimes I get these problems with. But then we don't have any errors, so let's just continue. And then now we are running both jobs in different Go routines. They would run concurrently to each other. But we want actually to read the result from the channel, right? Because then, like, both jobs are writing to the channel, So we want to get the response. And then now we can create a new function to wait into this channel and then read the results. So we can just create a new function called wait for response. And then we pass our variable that we defined here as results. And then we can just implement it. And here we receive a results channel. We need to specify the type. So this is a results variable of type job result. And first we read from the channel using the syntax. So the channel is sending the result to my variable result. Then I assign this variable. And now I want to know which response I got. That can be either from the XBot API or the VexBot. And it also can return an error, like since we define in our struct. So let's just check this first. If we have any error, we just return already, and we don't do any more work. So we just check if result.error is different from new. Then let's just print for now this result. So here, again, just formatting the string. The first one is our result.id, so we know which job failed. And the second is just the error. Supposing that everything went okay, we go into an else. And then here we can use switch. So we will switch on the result, and then we will have the cases, like the case for the VexBot response, the case for the XBot response. And this in Python you could use doing lots of ifs. But in Go you can try using switch, which is similar, I think, also to Java, right? Java also has a switch case and other languages. So for now we will switch on our result. And then here we do a type conversion. So this would be similar in Python as instance, like checking the instance. So we have a first case, like if the result is a XBot response. Then let's also just print successful. And here we pass our response. And we do the same for VexBot. And in case we don't have any of those, we also want a default case, right? So we'll just for now print that we don't know. Then we also would be good to see the response here, what we get. Right, so now we have this logic to just get the result from the channel and then print. And we can call this in our main function. So here we call once. It's also called another time. And any of the APIs can return first, right? It depends on how long it will run. But let's just run this for now and see what we get. So now you see that we have, like in this first run, I actually got the vexbot first, and then the xbot. So it can alternate, and then it can change depending on how slow one API is compared to another. Yeah, so I think that's it for this section. Now I'll hand over to Dominik.
Yeah. Yes, it is. So you wait on the channel until there's a response. Potentially that could block indefinitely if there's no response. So in a case where, there's an arbitrary number of messages that could come, you would probably put that in a separate Goroutine again. So it's fine if that blocks. Oh. Does it work anyway? Not really, huh? All right. Does that look better? All right. So, check. Okay. Cool. Right. Next step. So you saw this little bit sad message about the canceling that asked us to please implement it. So let's do exactly that, I'd say. Where do we start? I think best we start here. All right. So to make an API, so when we cancel the job, what should it do? Ideally, it would cancel all the outstanding API calls, right? Because they might be long running and we want to stop this. Also, they might be incurring a cost on the side that we're calling. So we want to cancel our HTTP request. Right now, we don't really have access to our HTTP request, right? It's just this http.get. Can't really cancel that. Wouldn't know how to. And this is one of the nice things in Go, is the standard library is quite flexible. So on the one hand, it gives you these really high level, I'm just going to do my job with meaningful defaults, and hopefully that's okay. But it also gives you a lot of control over the details if you want them. So what we will do is, instead of using this very high level function, we'll go one level deeper down. And for this, we'll use an HTTP client. And if you use an HTTP client, it quite often makes sense to share it between all the API calls you want to make, because that way, once the TCP connection is already connected and there's a keep alive enabled, which by default it is from Go's side, so if the server also supports keep alive, the connection actually stays open. So if you do several requests with the same client, you don't have to do a handshake every single time. Also, because to be cancelable, we need to modify the client a little bit, and so we don't want to do this in every single API call. So that's another reason why we pass it in as a pointer. Right, and instead of doing the call right away, you create a request. And you do that with a context. And this is still a GET request. It's still going to the hexbot URL. And the final one, there you could if it would be a post, you could pass the post body here. It's not a post. We don't need it. It's nil. And you see us that left something empty here. And context is a little bit of a tricky thing. But for the purposes that we use it, it's going to be a cancel context of type context. And we're going to pass it here, which basically means from the outside, I can create this context, pass it into the client here, and when from the outside I tell the context, stop everything that's listening to you, our HTTP request will be cancelled. There's other things you can do with the context, but this is as far as we go here. And this is just kind of Go's way to be open for outside injection. Right. So we have an error. So as we have an error, we should check the error. If it's not nil, basically give up. So now we created a request, but we never actually made a call. So this is going to happen now. And we just passed the request we created up there. And from there on out, it's basically the same thing. So we don't need to change anything anymore. Undeclared name context. Right. All right. There we go. Yeah. We have to kind of do the same for the vexbot. So let's do that. Well, my IDE is smart enough to delete imports that I'm not using, but sadly not smart enough to import the ones I'm using anymore. Well. Right. So. Basically copy paste the same things here. So we get a context, we get a client. And instead of just doing our nice little get, we now create request. And the only difference what you just saw is basically that URL here is different. Right. So, where does this magical client come from? Yeah. It should both be pointers. Yeah. There's a pointer here.
Sorry, the context.
It's a bit tricky with interfaces. This is actually going to be a pointer. You can pass a pointer here. Interfaces accept everything that has these methods, which can both be a pointer and not a pointer. It's strange. I agree. All right. So yeah, where does the client come from? Well, I mean, the thing that's calling these APIs are the jobs. So obviously, the bots have to be aware of this. And this is now where kind of our init function, our constructor, comes into play. So again, this one actually doesn't create the client, it just gets it passed in. If I find the star. But now it does something to that client, and that's creating a cancel context. So right, I'm going to explain that in a second, because this, again, is maybe not super obvious what this does. Right, so, context background, don't know where that name comes from specifically. This is basically the non-nil empty context, which also is what the docstring says there. Don't ask me why it's called background and not default. This is how you initialize a new context. And then we say, well, this context Shouldn't be anything special, but it should have a way to be cancelled, which A gives you a modified context, which now is cancelable, and a function that you can use to cancel it. If I call this function, the context is cancelled. Every HTTP client that uses that context will also cancel its requests. Now I have these local variables. How do I make sure that later on when I want to call cancel, I actually still have a reference to these? And in Python, you would probably now write something like self.cancel context equals cancel context. And this is pretty much exactly what we're going to do here as well. Or maybe not. So basically, we add these as fields on our struct, which has pretty much the same functionality as assigning it to self. And also, you want to keep a reference to this client. Right, now Go is like, well, I mean, I'm a typed language. You said my struct doesn't have fields, but does it have fields all of a sudden? So we need to add the fields up here as well. Cancel context. And a cancel func. Yeah, thank you. And HP client. Right. So now Go should be happy again. It's not 100% happy because we said, well, this API call now actually expects a context and a client. Well, luckily enough, we just created these. And now Go is happy again. All right. But we did all of this to actually be able to cancel stuff. So now we can actually implement our lovely cancel function here, which is as easy as calling the cancel function that we provided. So now you see this really behaves a lot like self, right? So I assign stuff to my object, which is a struct in this case, and I get a reference to that object, and I can call my methods on it. Cool. I'm going to do the same for Vexbot. So I'm going to just do it from the top to the bottom. Adding the fields to the struct. Actually calling the cancel function. Passing it to the API. And then in the constructor, creating the context and the cancel functions and assigning them to the struct. And of course, actually expecting the HTTP client here. All right, let's just make sure this actually still runs. Right, it does not, because now the jobs expect the client. We never created that client. And normally you do that as far out as you can to be able to share the pointer between as many clients as you can. So we do it in the main. And creating a client isn't terribly tricky. Should we do this? Here. So basically we say our client is the HTTP default client. Default. And then we just pass it in. And we said this has to be a pointer, but you can really tell this is a pointer. But if you have it there, you see the default client actually already is a pointer. All right. Cool. So it still runs. That's good. And I mean, we did a lot of changes, but it does the same thing. So let's actually cancel stuff. And this is relatively straightforward. So instead of directly reading from a channel, you can, it's a little bit like the concept of a generator. You can have a select case and select from several channels. So you kind of have a meta channel that wraps the other channels. So for this, we write select. And then we say, well, we still want to keep that case. Hopefully things are still fine. Slips all the way down here. Right? So right now it would still do the exact same. It's just now a channel wrapping exactly one channel. It's not terribly exciting. But we can now add another case. I'll always be confused with that syntax, but I think it needs to go here. Right. So there's a built-in channel that just sends a message after a given time. So now we can either get a message from our results channel, or we get a message from our timeout that runs out after a certain time. And here we're going to iterate over all the jobs that we have. And I haven't written this part yet, but we're going to have an array of all jobs. And this is basically a for loop in Python. This range keyword turns an array into something that you can iterate over. And this underscore, you would automatically get the same thing you get when you do enumerate in Python. So you get an ID that just increments. We don't care about it. So we do an underscore just as you would in Python. And now we actually cancel things. That's why we did all of this for. And just so that we are aware we did this. US keyboard. Don't know where %sign is. Where is it? Where's the %sign? There. Right. And yeah, just again, we print the ID just so we know what's going on. Right. So now you see made some assumptions. I said we have an array of all started jobs. So let's actually parse this. Started jobs, which is an array of jobs. So that's assumption number one. And the other one is I have a timeout defined somewhere, and I'm just going to make that a const. And Go has an interesting way of defining times, which is basically you say the number, and then you multiply it by the right kind of thing. So you could write minutes and milliseconds and whatever here as well. All right. Just one small modification, because we actually, when we wait for a response, we kind of want to know, did we get an actual response or was it a cancel? So it's just going to return a bool. And here we say, no, everything's fine. We did not cancel, so return false. And here we said, nope, we got cancelled. Return true. All right. Now we said we need this array of all started jobs, which is what we're going to create. And then as we create the jobs, we append them to this array, which again is pretty similar to how Python does it, but with a slightly different syntax. So append actually is a function, not a method. And started jobs. Appending the other job as well. Right. And here you can also see this is actually declaring an interface, right? So this is what we did this work for. So now we can have an array of just job, and we know it contains things that we can call cancel on. This is just due to the interface. All right. So now we potentially might get 3 responses, right? Because cancel would also give us a response. So we say cancel 1. Cancelled 2, just to know whether one of the 2 calls was actually a cancel call. And we pass the sorted jobs here as well. And then if one of the calls got cancelled, where's the pipe on a US keyboard? There. So this is kind of the OR syntax of a lot of languages, just not Python. So if one of them got cancelled, we want to actually still see the response of the third API. Right. Cool. So let me just print. Oh, so actually we can run this now. So right now nothing should have changed because they're not as slow as 2 seconds. But if we, for example, change this to 1 second, they probably still can do. Let's just say whatever, 2 milliseconds. Now we should actually see them getting cancelled. Yeah. So here we see the timeout kicks in, it cancels both of them, and the job still return because we have this error object, right? So the job returns, but instead of a result, we get now an error object, and the error reads the context was cancelled. All right. This is actually as far as we wanted to get today. There's more steps online that you can follow. If you have questions, you can write emails to us about the following steps, which will then explain how can we use these results, how can we turn this into a server, because then you have Goroutines running on Goroutines. For every request you get on a server, you start a Goroutine. That Goroutine then starts Goroutines for all the API calls, and then it all comes together and is sent back through channels. All right. Thank you very much. We have 3 minutes for questions. Oh, yeah. Thank you. I have no idea what the order was, so just going to go from left to right.
Can you comment on the possibility of calling Go from Python? And if it's difficult or easy or...
I haven't tried. So no, I cannot comment on it. I'm not aware of an easy way to do that. But I mean, you can integrate C code in Go, and you can integrate C code in Python, so maybe there's a way to do it. I haven't tried. I don't know. I mean, you can obviously, the nice thing about Go, it compiles down to a single binary, right? So if you can do system call the binary, let it do its thing, and then read the results back, right? So if you just want to use Python for orchestration and run some Go binaries in between, that's pretty straightforward and easy. Yep.
My question is regarding the why you choose exactly this way of doing business, not others in your company? Why Go, not others?
Yeah. I mean, I wasn't around. We were one of the very early adapters of Go like 5 years ago or something. I started the company 3.5 years ago. So I wasn't around. But mainly we have a lot of traffic, but we're not doing anything too fancy.
What's the number?
Number of requests is several hundred per second. So the nice thing is you don't really have to care about scaling as much because it naturally scales quite nicely just by language design. And as I said, we don't do anything too fancy. Like we have other projects that are in Python in the company as well. Like when we go more into like data engineering, machine learning, we use Python, but for things where we have the feeling this is a small thing, it doesn't do much, but it should be doing it fast, we use Go. Yep. Yeah. So a lot of people use it for infrastructure stuff as well. A lot of parts of Kubernetes, for example, are written in Go. So yeah, also when you really want to be kind of close to the metal system programming and you don't like C as much, Go can be a good choice because you can go quite low. You get access to a lot of things, but you don't have to, for example, care about garbage collection yourself, right? So that's good for that. And yeah, and generally like high performance stuff. I think there's now slowly some machine learning and data stuff also happening in Go. But I haven't used that for that yet, just because the Python ecosystem is just way ahead there. Any more questions? We have 0 more minutes. Oh, great. Okay. So this is step 5. So there's 4 more steps. All right. Thank you very much.